morning and good afternoon, everybody. Welcome into another very exciting Exploring by the Seat of Your Pants broadcast. If you're joining us for the first time, like some of you are today, including our speakers, we are all about bringing conservation, adventure, and science into classrooms around the world. And as you may know, everything we do goes to our YouTube channel. So in like 3 weeks or 3 years, you can check this out, tune in. There's like 4,000 broadcasts there. Pretty much every cool scientist and explorer this planet Earth has to offer. So please do take the chance to check that out. And you're catching us in a very exciting day. It's Friday, for one thing, so the weekend's coming up, which is always a good time. But we are beginning a new series in conjunction with our friends at Project Learning Tree. So for years, we've done little stuff here and there with Project Learning Tree, but we've never done a full dedicated series. And so this end of this week and all in the beginning of next week, we are going to be featuring all sorts of green careers in and around forests. We've got fighting forest fires. We've got planting trees in cities. And today, we've got the creepy crawly and flying things of the forest with Darren and Joe. So I'm so excited. We're going to get the chance to hang out with the SFI lead scientist and Joe from NRCan right here in Corner Brook with me. Not very often we get to have people in Corner Brook, so I'm very, very happy that Joe's like right down the road from me. I can probably yell and talk to him if I want to, which is always a good time. So without further ado, I'm going to bring in our two speakers. We're going to lead in with Darren and then take you to Joe, and then we can't wait for all your questions. So, gentlemen, thank you both so much for being here today, and welcome to the broadcast.
Thanks, Jesse.
Thank you.
Joe, we're going to be back to you in a minute, but I'm going to let Darren kick us off. And if you want to bring up your presentation, I can zip it. I know you've got a lot to share with us. So let's dive in and do this thing.
We're getting there. We're coming. We're coming.
Almost there. Drum roll, please. Jeopardy theme music. And we're almost good. You got to go full screen with it. We got the slide deck still on the left.
Uh-oh.
It worked in practice.
Okay. Okay. Don't panic. Don't panic. Don't panic.
Darren and I, we practiced this just before we went live, and it was all queued up. And I said, sometimes when we go live, that's when it doesn't want to work, and that's half the fun, really. I think
this time it's gonna work.
It's personal.
I can feel it.
And we are almost. No, there you go. Cool. You're golden. Oh my goodness. Take us away, man.
Okay. Thanks, Jesse. As Jesse said, my name is Darren Sleep. I'm the lead scientist at the Sustainable Forestry Initiative and Project Learning Tree. And I'm happy to be here today with my colleague, Joe Bowden, who's a research scientist with Natural Resources Canada. Now, I'm going to let Joe take care of who he is and what he does, but I want to tell you a little bit about what I do. So I am a wildlife biologist. I'm from New Brunswick originally, where I studied owls, and then I moved out west to Saskatchewan, where I studied bats of all things. And then throughout my career, I've studied lots of different critters, whether they're birds or caribou or owls. I've studied a whole bunch of stuff, and I've worked right across North America on a variety of species. Now, I do really prefer to work at night or in the winter. I don't like it when it's hot and sunny. I like it when it's cold or dark. So I've spent a lot of time working at night, putting my headlamp on and running through the forest. And for the last 20 years or so, I've been working with forestry companies right across North America to help make sure that they are managing their forests in such a way that wildlife and other things we care about are protected. And as you might have guessed already, I love forests. All of my work has been done in forests. I love being in the forest. I love camping in the forest. I love playing and working and researching, and I just love forests. And all of my work has been focused around forests and how we manage those forests. So when we talk about managing forests, we're really talking about what's called sustainable forestry. We don't want to go in and cut down all the trees and just move on to the next trees and just leave everything a mess behind. But we actually believe in managing the forest so that the forest is well taken care of, and all the things we care about in the forest, whether it's a place to go camping, whether it's the wildlife and the biodiversity, whether it's the carbon that the trees capture and help fight against climate change, all of those things must be managed over the long term. So forests are really cool this way. If you manage them well, if you harvest them and replant, they come back, and all of those things that are part of a natural cycle of the forest gets maintained, and we get all the benefits from the forest, like something to build our homes with and something to burn and heat things with, and all the paper products you use in your house or in your classroom. So sustainable forestry is this really amazing thing. So while we're talking about forestry, I want to highlight this application that you can go play around with. It's called Forest Quest. Project Learning Tree Canada put this together a few years ago. You can go in there, you can explore what it's like to manage a forest and all the different values and different scientists and different careers within the forest. It's a really interesting little it's like a game really that you can go in and play around with and learn about forests. But what is forest certification? Now, I work for what I mentioned already, Sustainable Forestry Initiative, or SFI. And SFI is what's called a forest certifying organization. So what we do is we develop a checklist that companies can use to, when they're managing forests, they can check to make sure they're doing all these things so that the forests are protected and maintained over time. So we make sure that trees are not harvested faster than they can grow. We make sure that wildlife and biodiversity and bugs and birds and everything is protected as much as possible. We make sure that the water is protected, so the water, like the streams and the lakes and forests, don't get messed up. We also make sure that trees are regrown after they're harvested. So not only do they get planted, but they get checked on over and over again to make sure that the trees are coming back properly. We make sure that Indigenous peoples are respected and their rights are protected. And we make sure that people in general can enjoy the forest both now and into the future. So once a company has taken this big, long checklist and made sure they're doing all these things, they get to use a label that they can put on their product in the store. So you will find these labels on paper packaging and things like that at your grocery store. And what these labels mean is that forest that the product came from was well managed and maintained over time and protected. So this is a way that companies can signal to people that are buying the stuff that they are taking care of the forests where these products are coming from. Now, again, I work specifically for SFI, and SFI has lots of different things we do around sustainability. We don't just promote responsible forestry and sourcing. That's what we do with our checklist that I just talked to you about. But we also have a science branch. We have a conservation team that works on nature-based solutions. So that, we're doing all kinds of research to learn more about the forest and to provide solutions. We also have PLT Canada, which is about fostering a lifetime of learning. It's developing stuff for your teachers to use, for classrooms, so we can promote education throughout it. And we also have a community team that works to create this positive change within all the communities that depend on forests, whether they're Indigenous communities or disenfranchised communities, or all kinds of people benefit from the forest. And we have a whole team that's focused on making sure that those communities get benefits from the forest. And again, once a company is certified to SFI, they can use these different versions of our logo, and these logos not only appear here in Canada, but they appear in over 150 countries around the world. So you will see this logo appear all over the world on products that are certified to SFI. Now in Canada, over time, the amount of forest that has been certified to SFI has increased. And you can see that this graph just shows over time since 2000 now to 2023, 2024, the number of areas, number of hectares rather, the amount of space that is certified to SFI has been growing over that time. So when we talk about Canada, just specifically, I want to focus on Canada. Most of the folks on this webcast are coming from Canada today. Canada's forest is massive. The amount of area that we have in Canada that is forested is huge. And it's very different depending on where you live in the country. If you live, for example, if you live in Northern Ontario, you're in the boreal forest. It's one kind of forest. If you're from where I'm from in New Brunswick, it's called the Acadian forest. It's very mixed and very different than the boreal forest. Out west, if you look at the orange or the yellow areas, those areas are mountainous forests, montane forests, and different forests that are very, very different from the rest of Canada. So how you manage a forest will depend on where you live in the country. So it's a highly varied across the entire country. And on top of that, our forests are changing, and they're changing at an alarming and rapid rate because, you've probably heard of it, climate change. So climate change is really changing almost everything we know about forests and how we manage it. Every year, more and more of the forests in Canada and North America are burned in wildfires. Summers are getting hotter, summers are getting drier. So we have to continually do new research to better understand the forest and inform how we manage those forests. So what we do, over here on the left, you see this standards and rules. This is our forest management standard. That's that checklist that people have to go through to make sure they're managing the forest well. So those standard rules inform how the forest is managed wherever you are in North America. That label then appears on different products in your grocery store or your hardware store. But we use some of the work we do to generate research around water or biodiversity or carbon, so we can then do conservation and better inform the next time that we revise these rules, which we revise every 5 years. When we revise those rules get better because of the new research that gets brought into it. Not just the research that SFI does, but the research that communities in general do. Now, how we do this research specifically is we work with outside people. We work like folks like Dr. Joe Bowden, who you're about to hear from, about doing research that we can use to inform our standards. And with that, Jesse, I'm going to stop sharing and I'm going to hand it back to you, and you can hand it over to Joe.
Well, thank you so much, Darren, for a deep dive into some of the amazing stuff that SFI does. We're going to make sure that everyone has that link at the end as well, so stay tuned for an email with our Forest Quest, especially for our classrooms, and really appreciate that. If any of our YouTube or StreamYard audience have some questions, Darren, do stick around, of course, that we can field those your way in just a minute, but I'll put you in the background as we bring in Joe to talk about some of his experience in entomology with some really cool insects and beyond. So, Joe, welcome to the program, man.
Thank you so much. I'm just coming into the
go take one with you.
I think it's gonna work. I think it's
gonna work, baby. Kind of, sort of. Oh, I can walk through anything. So we've still got your slide deck to the left, but if we go full screen, we're good and perfect.
And then
and
I need to.
If you want to drag that little, you had it before.
Okay.
At least you both had some troubles. That's kind of exciting.
Thank you very much.
So Joe, you do have to go to display settings. You had it better the other way.
Oh, sorry.
That's okay. All good.
Is that better?
That's much better. You're golden.
Super. Okay, thank you, Jesse. Hi, guys. So my name is Joe Bowden, and as Darren already told you, I'm a research scientist with Natural Resources Canada, the Canadian Forest Service, and I am a forest entomologist. That means, really, I guess, in plain terms, that just means I am a forest insect scientist. And I've been interested and fascinated by insects and bugs since I was, wait for it, knee-high to a grasshopper. And I will try to limit my insect cliches throughout this talk, I promise, but I had to throw one in. So I just wanted to start off with, for this talk, I'll talk about some of the projects that we're doing in collaboration, as Darren mentioned, in support of SFI's biodiversity initiatives and their policy goals. But I wanted to start off, and I'm going to try to be very broad when I talk about forests and forest insects and insects in general. I think most of you will not disagree with me that this is a photo of a forest with a student hiding behind this fir tree in the background. It's one of my master's students. But I do have a quick question for you guys right off the get-go, and that is this a forest? So we've established that the previous one is a forest.
Yep.
We're not going to argue that one, but this one, is this a forest? So we see photos of all kinds of different flowers, goldenrod, fireweed, pearly everlasting, some grasses and things like that. Is this a forest?
Mrs. Fisher, I can come to you guys live. What do you think? Is it a forest?
Do we think it's a forest? Yeah.
Yes, absolutely. There's trees there. There's plants galore, Joe.
Great job. So this is just a young forest. It's a forest that's been harvested. So Darren talked, you're all forestry experts now because Darren explained everything to you, but this is just a very young forest. And this is what we would call part of a chronosequence or a historical harvest of forest. This one is about 10 to 15 years old, actually. So we see some trees in here growing back, and eventually they'll be harvested in another 40, 50 years. Is this a forest?
Take two. Oh, Darren's nodding in the background. Mrs. Fisher's class. What do we think? What do we think? Yes? Yeah?
Yes.
Kind of,
so there's
maybe a little less enthusiastic on that one.
A little
Joe.
less exactly. So this is just a very much younger forest. So we see, of course, a lot more grasses and flowers and things like this. And my colleague Lucas Brejo walking through this site, but this is a forest. Again, it's just a very young forest. So this plot was harvested about 5 years ago. But already we see a lot of these young balsam fir trees growing back in this forest. So it's regenerating. And there's a big difference, I think, in between forestry and what we hear about a lot in the media, like deforestation. So this is a forest that is going to come back and become a forest again. And I'll circle back around to this in a bit towards the end when we talk about the project that we're doing in collaboration on plants and pollinator diversity across this whole Croto sequence of different forest ages. So I wanted to start off, as a scientist, we ask a lot of the same questions that you guys do when you're writing stories or reports for class, or like even police investigators or what have you. So anyone that wants to know the answer to something, we often ask those beautiful questions: who, what, when, where, why, and how. And you could sing a song to this: who, what, when, where, why, and how. But my point that I really want to drive home here is that we still don't know the answers to a lot of these basic questions. So these who, what, when, and where are usually the very first questions that we can answer, the very easiest kinds of questions. So who was, in a given place, which species are present in a given kind of forest, and what does that look like? What do they look like? When were they there? But getting often at the questions of why and how can be really challenging. And that's why we need science and research to sort of get at some of these more difficult questions. But just to highlight this, some of the basic questions like who and what are actually we still don't know a lot of the who and what for a lot of places across places like Canada and the United States. So just thinking about like species in particular jurisdictions, like I'm in the province of Newfoundland and Labrador. I've been on the hunt actually this week, and proof that I'm an entomologist. I've got my butterfly net in the background. But this week, spring has just sprung here in Corner Brook, as Jesse can attest to. But I've been on the hunt, searching all around Tyneside because I've seen this beautiful orange moth flying around, and I'm pretty sure it constitutes a new provincial record. So this is, again, part of that who. We don't know often who is where at a given time. I wanted to start off with a beautiful bunch of photos of butterflies. And you'll notice quickly that there's no monarch here because we don't have monarchs here in Newfoundland. There's no host plant, the milkweed, which you'd probably be used to seeing monarchs in most of continental North America. But I want you to think about, what are these guys doing out there? What's their importance? Yes, they're beautiful creatures. That's one of the reasons I wanted to start off with butterflies, because they're a very charismatic part of the insect world. Maybe we'll do one more quick question. How many species of butterflies do you think are in the world, in an entire world?
Ooh, okay. And YouTubers, I'm going to give you guys a second to put your thoughts in the chat too. Ms. Riddle's class, Caesar, Ms. Moison's just joined us with a wicked Oilers jersey way to represent the West Side. So how many species of butterfly? Miss Fisher, how many kinds of butterfly do we think there are in the world?
1,000.
About 1,000, okay.
That's
Ms. Moison's
guess.
class, if you guys want to chime in too, I can come to you. What do we think?
Yeah, that guy. What's that guy's name?
Hi guys, welcome in.
Who's this guy's name?
I got a few hundred in there. 10,000, over 100 on YouTube. So all over the place, all multiples of 10.
Really great guesses. And the 10,000 was the closest. There's about 17,000 species of butterflies we know globally around the entire Earth. In contrast, we know of about 160,000 species of moths. So this is mostly what I work on, is the night active Lepidoptera, or this group of insects that flies around mostly at night. But so that's this is a group of insects that is attracted to light, this moths, and we use things like light because we know that they're attracted to light. Some of the other ways that we go about sampling insects in the forest are using pole pruners, these big long poles that we do to access the roof, the canopy of forests. We also use things called flight intercept traps. So these are traps that we use to sample things like beetles, and we can bait these with different pheromone smells of the forest and things. But often we're out there searching for things, and this is really just a juvenile moth. This is a spruce budworm moth, and every once in a while it becomes eruptive and it causes a lot of disruption to the forest. It does a lot of rapid feeding and is one of these really broad scale defoliators that causes a lot of feeding and destruction in forests. Sometimes we get to use really cool equipment. So I'm involved in an international working group that's working towards the automation of detecting insects out there. So we're using these fancy cameras and lights. These are a bunch of moths here, so basically related to butterflies again. And this is constantly taking pictures throughout the night and cropping out each individual when we pop that into our online platform that we use to document species. So again, trying to get at some of the who and what and when kind of questions that we still don't know the answer to for a lot of insect groups in our forests. I was lucky enough to join a butterfly conservation conference in the UK about 2 years ago, and lucky enough to get a tour at the Oxford Natural History Museum, which is a fantastic museum, lots of history there, literally. And then, so I was very struck by this sign and this display when I walked in that reads, there are 1.25 million species of known animal species on Earth. 75% of them are insects. So over 900,000, about 940,000, if I'm doing my math in my head correctly, species are insects around the world. And again, there's about 17,000 species of butterflies, and about 160,000 of those 940,000 of insects are just moths. And so it's one of these hyper-diverse groups of insects that really represents biodiversity. Insects are key components in every food chain. Without them, global ecosystems would collapse. And so I'm going to move on, but I want you just in the background just to think about what is it that the importance of the insects, what kinds of what we would call ecosystem services are they helping us out with? Are they providing us out there in forests or in our backyards or even in our houses? So first of all, I think a lot of you will come up with, well, they're important pollinators. And we often don't think about the importance of insects or moths working as pollinators in our forests. And indeed, there's a lot of flowers that are really important, that importantly rely on moths or nocturnal pollination. And we're learning more and more about this in terms of research that we're doing, and colleagues of mine are doing it in Europe on the importance of moths as pollinators. So we often think about bees and things like that, and sometimes flies also are important pollinators. But they're also in different stages. There can also be plant eaters. And so sometimes this is a bit of a disturbance. So they feed on plants, but they can also serve as an important ecosystem service when it comes to things like keeping alien invasive plant species down from spreading, for example, because they're feeding on them. They also serve as important food for migratory birds, bats, and other things out there like spiders and other insects, for example. And as Darren alluded to, climate change is really changing and reshaping a lot of the things in our forests, and insects are one of them. Entomologists often refer to insects as canaries in the coal mine for climate change, because their physiology is directly related to what's going on around. So historically we might call them cold-blooded organisms or poikilotherms, but really that means they're how much energy they're burning out there when they're doing the things that they do is directly related to things like temperature out there. And we know that temperatures are getting warmer, and this is causing things like redistribution of species. So even some of these native insects that some of my colleagues in Europe are working on have shifted significantly northward and are even doing things like defoliating the birch forest, so in this photo in the bottom, and then hopping onto the Arctic tundra and defoliating a lot of the dwarf birches and things like this, which is something we've never heard of before. A little closer to home here in like British Columbia, and even here on the West Coast, the most recent outbreaks of things like the western spruce budworm or the eastern spruce budworm have occurred much further northward. So we know that it tends to be these species that we would call pest species are moving rapidly northward and colonizing sort of new areas, and really changing a lot of the interactions that are going on out there in our forests and really on the landscape in general. Global shipping as well. And so humans have been really good at moving around when we travel, when we export and ship around goods all over the place. Global shipping has increased significantly over recent decades. And so this there creates what we would call stochastic or chance probability of increasing the introductions of species around the world. And so we need really good systems like I mentioned before, some of these automated systems that we've been working on, and there's been really great developments. I don't have time to get into it, but really good technological advances in our ability to detect species like alien invasive species really early so that we can respond to those quickly. there's not been a lot of historical data on insect declines, and you might have heard about in media or something like that about declining insect populations. Some of the best examples we have of data are actually collected, in the UK for one, but they're actually a lot of this data showing declines in insects over time was actually collected by folks like yourself. So they've been really good at doing what's called community science or citizen science. And so, in fact, a lot of folks out there can contribute to our knowledge about the declines in insect or the presence or absence even of insect species. And just like this moth that I've seen bombing around Corner Brook here, and I'm trying to get a specimen or a photo of it. Back to this chronosequence of forests. So, in partnership with Darren and SFI, we've been working on this chronosequence of forests. So again, these sites that were harvested 0 to 5 years ago, 10 to 15 years ago, and 20 to 25 years ago, and 30 to 35 years ago. So you can quickly see just by the visual images that these forests are very, very different. But the questions we have are really around plant and pollinator diversity. So we're starting to learn that in younger forests, there's an awful lot of flowers available for different kind of pollinator species. And then when we get to older, more mature forests, we get very different kinds of plants. And you can sort of see this even in an understory. So we're getting a lot more different kinds of plants, plants like ferns and mosses and things growing in some of the older forests. And that changes the availability for some of the insect species that are living there too. And then from a broader scale, as scientists, we want to make sure we're doing really good replication. So all of these colors are just colors on a map of when all of these different stands were harvested. So, we go and we want really good replication so we can go into these stands and study them and find out what's going on in terms of the pollinator diversity and the plant diversity in these systems. And we've got we're working with the local industry, with the local pulp and paper mill, with SFI, with academic partners, and with a local elder as well from the Halibu First Nation that has been really central in helping guide a lot of the students working on this project. And this is a photo of Elder Barnes talking to the students about the importance of the cultural ecosystem services, so the cultural importance of different plant species. And he's a knowledge holder of a lot of the medicinal plants or the food plants that a lot of First Nations have used in this region for hundreds of years. So one last point I wanted to make is that you too can contribute to research. As I mentioned before, there's been some really great data throughout history on insects provided by communities and by citizens. And so some of you might know about iNaturalist. A lot of people have phones on them now. You can post photos to these websites like iNaturalist and eButterfly. And help contribute data. So the other nice thing is that the machine learning is getting really good in these, so good that it will actually tell you and give you that instant feedback. If you ever see a butterfly or a moth in your backyard or a beetle and you want to take a picture of it, it gives you that instant feedback when you click on go to submit, and it'll tell you, start generating ideas of what that is. And then there's experts all over the world that are just ready to go and try to vet those images and really excited about documenting new species records across different places in our forest. I'll leave you last with a whole bunch of images. These are photos that I've submitted to iNaturalist from different moths that I work on in the forest, and I'll leave it. I think I'll leave it there for now.
Well, Joe, first of all, thank you so much for that. And we encourage a lot of our classes to use iNaturalist all the time. It's part of our Backyard Bio initiative. For our global friends, iNaturalist.org is great.ca is the Canadian sort of equivalent of that. I really can't encourage you to do it enough. I walk down the stream trail here in Corner Brook all the time, taking pictures, lots of submissions, and it's a really great way to help contribute to real science and conservation on planet Earth. So, Joe, Darren, welcome back. We're going to dive into a Q&A, gentlemen. So Ms. Moiston's class, Ms. Fisher's class, our YouTubers, please keep sharing those questions. We'll come to our live classes in just a minute. But one to kick us off for Darren, just broad strokes generally as we lead into this big PLC series. Forests in Canada, are they getting better? Are they getting worse? I know this is a big question, but can you tell us this broad strokes for our younger audience?
I can do my best. First of all, we know that we are not losing any forest. That's a good start. We know that the amount of forest we have in Canada is pretty much stable, has been stable for the last 20 years or so. So the amount of forest we have is not declining. That's important. The other thing to note, and I mentioned this in my talk, climate change is having a very strong effect, particularly in out west with burning. You might remember, just a couple of years ago, we had forest fire smoke blowing through all of our communities, and that was causing a lot of problems. So we are finding that more and more of our forests are burning, and that's a challenge to the forest. We have to continue to manage those forests. We have to continue to replant those forests. But that said, we're not losing forests, and the quality of our forest isn't noticeably declining. We have no evidence at this point that the quality of our forest is declining.
That's really good to hear. I mean, on the forest burning note, when I was a boy, we heard about forest fires occasionally, but it's every single year now. So for our students in grade 2, 3 today, when we have some classes like that, it's really unusual that every year half of Canada is on fire. Like, that was not the way that it was when we were kids. And so I always like talking about climate change, because it's great to have scientists who have real expertise in this come on. But I honestly, students, ask your parents, ask your teachers, ask how the weather has changed since they were kids. And in most cases, it's radically different, which is a big challenge. And it's also a big opportunity for us to make a positive difference. So thanks for that, Darren. Joe, next question goes to you, and no pressure on this. Do you have a favorite moth or butterfly? No pressure.
I do. There's 180,000 species of moths and butterflies globally, so it's a really tricky question. But I do have a couple of favorite moths. I think one of my favorites in this region, in the boreal forest, is called Habrocine scripta, or the Habrocine. Not a really fancy name. The moth I've been on the hunt for around town is really a gorgeous moth. It's called the infant, and it's orange, and it's got these white marks on its forewings. It's really gorgeous, gorgeous species. So,
cool.
Yeah.
If I find one, I'll let you know. I'll capture it in the backyard.
Super.
And we'll call you over.
Yeah, well, I'll be probably walking around. You'll see me.
Yeah, perfect. Mrs. Fisher's class, we're going to head to Carsonville now, and then we'll head to Ms. Boyson's class in just a second. Come on in. Hey, folks.
What's the biggest insect in the world?
Ooh, no pressure, Joe. That's for you.
Good question. So I sort of anticipated this one. So that's a very good question, because if you mean by mass, like how much an insect weighs, the heaviest insect in the world is found in New Zealand. It's called the giant weta, and they weigh about 75 grams. So I think it's about, well, you probably have maybe little weights, or you can have a scale in your classroom, but you can search up how much is 70 to 75 grams. That's pretty heavy for an insect. And then the longest insect, or the biggest insect in terms of the size, is called the Chinese walking stick. And these things can grow really, really long, about over half a meter long.
Ridiculous.
Massive
totally
things.
Ridiculous.
Yeah.
I really encourage everyone to look up the weta, which you can think of as like a super grasshopper. That's what it looks like. It's like if a grasshopper was on steroids and got really, really big. So they're a special insect. And we haven't had that question in a while. Thanks, guys. All right. We're going to head to our Alberta class, representing with, again, that Edmonton Oilers jersey. Come on in and take us away. Unmute that mic, and you're good to go. Hey, folks. Welcome in. Hi.
How do butterflies get their color?
Oh, Joe, back to you, man.
That's a very good question. And to be honest with you, I don't know the answer. There's a whole bunch of different. So the way that butterflies have gotten their color throughout evolutionary history is simply through evolution. So physiologically, I don't know how that works, but throughout history, butterflies, just like a lot of things, are adapted to operating in different environments. And so you've got things, if we think about the monarch, for example, it's a bright orange color, and this is what we would call aposematic coloration. It's a warning coloration to a lot of other things that might eat it, that says stay away. I'm a bright orange insect, and it picks up these toxins actually from milkweed when it's feeding as a caterpillar. And then you've got some really bland things sometimes, or more bland things. A lot of the moths, for example, are what we would call cryptic or camouflaged. And so they've really adapted. There's some really cool, one of my other favorite insects you just reminded me of is called Syngrapha rectangula. And I forget what the common name of that one is, but it actually mimics lichens on trees. So it hides out, and it looks like it blends in really well with lichens. So
neat.
That's my sort of discussion about color, I guess, but yeah.
I'm going to harp on something here too for a second. So as any of you live in a place with like hot summer will know, things tend to lose their color over time. The sun impacts them. It gets rid of that dye. A lot of butterflies and a lot of beetles and insects for that matter have structural colors. It's like built into how their bodies are. So hundreds and hundreds of years later, they're just as vibrant as they were when they died, which is really, really special and on a sort of global scale in the animal kingdom. So right. I love when we get this question about moths and butterflies. So thanks, Joe. Darren, I've got another one for you. You highlighted in the middle of your talk a little symbol that people can look for. Now, we do a lot of ocean programs where people look for sustainable seafood with marine stewardship, with Ocean Wise. Can you tell us where we would look for that symbol, maybe for our classrooms, what sort of materials they would buy and what it means to have that symbol on it?
In terms of paper products or paper or wood products, so if you go to your local Home Depot or Home Hardware and you look in the wood section, a lot of wood, you'll see a sort of a fuzzy stamp that's stamped on the wood. Usually when you're building a house or something, you'll shave that off or you'll cut that off so it won't be seen. But there'll be a logo that's actually stamped on the wood in some cases. If you go to the grocery store and you pick up maybe a box of Kleenex and you flip it over and you look at the back of it, you'll often see a little symbol on the Kleenex or toilet paper or any paper product like that. And then sometimes when you pick up another product that's maybe it's in packaging, it's got a box on it or something, sometimes the box will have the logo on it as well. So they're all on these different products.
It's just a way that we can sort of outsource the expertise to other people. It's really hard to know as students, as people just going through our lives, like what's the best kind of product? Well, the amazing folks at SFI sort of do that work for us, and then we can go and make those informed decisions. So we're not taking out forests that are, not going to be replanted, not going to be replenished. And I think that's a really, really important thing that we can all do our own small little part. Darren, we had a great question about forests as well from Caesar in Nicaragua. So he wanted to know, do these forests plant themselves or do we plant them? Like just by and large in Canada, are we doing a lot of replanting work? Is it just where we're letting the seeds blow on the breeze? What's the deal?
It's a little of both. And again, you remember the map that I showed you that the forest is very different right across the country. Well, how we manage those forests is very different right across the country. And what kind of forest you're trying to replant as well. So if you're doing a lot of aspen work, for example, that's like a trembling aspen, those trees tend to replant themselves. After you harvest, they actually sucker off of old roots, and you'll see that the trees will come up pretty willingly everywhere you go. We do still have silviculturists, forest experts that go in and make sure the forest is coming back properly. They don't just trust that it will be there. In other places, we do a lot of replanting. We actually, you can get a job as a summer student, once you're in maybe a university or sometimes late in high school, where you can go out and you can walk around with big bags full of little seedlings and stick them in the ground. It's hard, grueling work, but it's very appreciated. And you get a job for the summer walking through clear cuts, planting trees.
One of my best friends used to be a tree planter. And in fact, we've done a lot of gross morn programs here in Newfoundland where they're literally planting trees live on camera. It's a really, really special kind of broadcast. So I'm so glad you mentioned that. Thanks, Darren. All right. We got a couple on that. We're going to do 4 more questions. The final one we're going to do is for both of you from Alexis, which is a great question. But we're going to head to Mrs. Fisher's class, Ms. Boyston's class, back to back. Come on back in Carsonville. Hey, guys.
How old can the butterflies live until?
Ooh, Joe, how old do butterflies get?
Very good question. So they can live up to a couple of years. So it depends. Here in the north, and in mostly most of the species that I work on are live for about 1 year. So it takes about 1 year for them to go through their life cycle. But some species actually live for a couple of years, and it takes, because typically and historically in colder environments, it takes a little bit longer for them to build up and get big enough as they eat as caterpillars throughout their life cycle. That's when they're really growing rapidly, is they're eating as caterpillars, and they're growing and they're getting bigger. And then actually a lot of insects, a lot of moths and butterflies as adults don't even eat because they don't need to. But a lot of butterflies and moths will feed on nectar and things like that as well.
Yeah. Very cool. I will say, as an ant guy, some ants can live to like 20 years, so we win, but that's okay. Good to know that moths are a couple of years. We're happy for you, Joe. We're going to take one from YouTube really quick, and then we're going to come to Alberta, but this is a nice one for Darren. How do we find out what trees are best to plant for our area? Is there a place to go for this on SFI or PLT or whatever?
Oh, that's a great question. And, I don't immediately know, but often if you have, for example, if you have a forestry company, if there's companies that do work in your area, they're harvesting, they can generally tell you what they plant. The general rule is you have to plant what you've harvested. So, for example, if you're in the Acadian forest, you're harvesting a mixed forest, you generally have to plant back a mixed forest. But really, if you go out to your nearby forest, it's not hard to identify what's out there. You have to be careful in some cases. If you go to like a nursery and you want to buy a tree for your backyard, for example, often they will give you trees that grow really well, but they're not actually native to North America. So you got to be careful about that.
It's very, very important. As I put you back in the background, I'll just say I have a little sequoia seed or acorn on the back here, so I could grow the biggest thing on planet Earth, but I shouldn't do that in Newfoundland because they're not from here. So as cool as it would be to have an epic forest in my backyard, it would take out the house. It'd be very bad in all sorts of ways. Ms. Moison's class, come on back in and take us away. Hey, folks. Hi.
Why are beetles black and how old do they live?
Ooh, your audio is just cutting out the tiniest bit. So what I'm going to have you do is write that question in the chat on the side, and I'll make sure we get it in, okay? I caught half of it, but I want to make sure we don't miss any part of it, okay? So thank you very, very much for that. I'll go to Mrs. Fisher's class while we're waiting for you to write that in. Come on back in with your final question, folks. Hi, Mrs. Fisher's class.
How many forests are in Canada?
Could you repeat it for us?
Forests are in Canada.
How many forests? Yeah, how many forests in Canada?
How many forests? That's an interesting question because there's actually about 7 to 11 different kinds of forests, different what we call ecozones of forest. But as far as how much forest there is in Canada, there's about 300 million hectares, and that's really a hard number to put your head around, but it's really big. We have a lot of forests in Canada.
We're mostly forest. We've got like this little band of city right along the U.S. border, and then it's like forest.
And lots of water. We got lots of water,
too. We're very lucky here in Canada. We got a lot of good stuff on the go. Where you go, Joe, 33 times the island of Newfoundland in forest. That's crazy, and we're a big island. All right, Ms. Moison's class, thank you very much for sharing this in the chat. I'm sorry the audio's a little late, but why are the beetles black, and how old do they get, and can they survive a forest fire? Joe, that's for you, man.
Sorry, can you repeat that?
Yeah. Why are the beetles black, and how old do they get, and can they survive a forest fire?
Okay. Okay. So I'm guessing you might be talking about some of these really longhorn beetles that we find across the boreal forest and you would see out in Alberta. There's a couple of different species. This is in the genus Monocamus, and this is a native beetle. They look like aliens, these really longhorn beetles. They're beautiful, but so they're a natural part of boreal ecosystems, and they tend to feed on stressed or dying trees. And actually, they can, in some ways, survive forest fires because they, as larvae, they actually live inside of trees, deep inside of trees, and they're feeding on these stressed trees that don't often burn entirely. A lot of the outsides of trees burn up. So you see a lot of standing deadwood after trees, and there's a lot of beetles still living inside those trees.
How cool is that? Some of the adaptations to survive forest fires and to thrive in forest fires, that we've covered these before, they're really, really special.
There's a whole suite of beetles that we call pyrophilous beetles. So there's a whole bunch of beetles that are actually attracted to forest fires. They've evolved to detect those chemicals that are released by burned areas, and they are attracted to those areas because they know that's where they're going to find these sort of dead trees that they can feed on.
Joe, that is super, super cool, man. Thank you so much for that. And this final question goes to the both of you. So we're going to start with Darren. Okay, what is a piece of advice you would give to scientists that are sort of aspiring scientists from your own careers? No pressure.
Okay, I'm going to start with, if you're going to be a scientist, get interested in like, dig into something that really interests you. Science is a slow process. If you're doing work on a research topic that you're just kind of like you're doing it because you have to do it, it's hard to stay focused on it. But if you look at Joe and you listen to the way he talks about bugs and moths, he's super excited. He's going out at night when he's not working anymore, running around with his net trying to catch stuff. If you are passionate about what you want to do, for me, it was always owls, it was always bats, it was always night stuff. I wanted to go out at night and see things and try and catch things. Follow what you're really excited about. That would be my advice.
There's no better message than that. That's fantastic, Darren. And then Joe, I'll bring you in. You were talked about in that answer, but if you have a
I agree. Well, stay in school for one, but I think I would agree with Darren is that there's a lot of ups and downs as you go through school, as you go through your career, and so being really super passionate about something, and you're going to learn about all kinds of fascinating things as you go through school and later in high school and university and things like that. Things that are going to be really, and a lot of really interesting technology is going to come and be developed. And I think if you have a passion for something, that's gonna keep you focused on scientific discipline.
If you can find something that makes you as happy as Darren and Joe are to do their jobs, whatever that may be, it could be history, it could be sports, whatever, you're going to have a very, very happy life, get to work with all sorts of cool people, have a lot of fun at every stage of the process. So I love this message from you two. Thank you so much for kicking us off on a really, really exciting part of our PLT series. So 4 more programs to come next week. I can't encourage you enough. Check out Forest Quest, check out inaturals.org. There's so much to explore and discover there. And gentlemen, what we do to wrap up every program, I'm going to bring in our classes to say a big thank you and farewell. For our folks on YouTube, if you want to yell and scream at home and annoy the principal, you have our permission, so please do. Mrs. Fisher's class, Ms. Boyce's class, thank you so much, everybody.
Thank you.